Yeah, a very good evening, everyone. So, welcome to the third lecture of social network analysis. So let's start with our today's lecture. I hope my screen is visible and I'm audible to everyone.
Yes.
So yeah, so first of all, let's quickly take a recap of what we have done till now. So in the last lecture, we have tried to understand that why like understanding NLP concepts is important in social media analytics. Why do we combine these both and why like we are focusing these two lectures on NLP and teaching you the concepts of NLP. So yeah, it's important because like a lot of data on social media is about text, right? We have the feedbacks, we have the comments, we have lots of documents online. So whenever we are analyzing those documents, so there because all the data is in textual form, so it is important to study NLP. Okay, so then we have seen that there were certain challenges in while analyzing social media data. So what were these challenges? The challenges were that generally whatever data we have in social media in the form of comments or feedbacks, they are generally not grammatically correct. There will be some spelling errors, or sometimes we use some slangs or some popularly used short forms of the words. So because like we are not using standard language in social media, so it becomes challenging to analyze such kind of data using NLP. So then like we have studied that because like this data is in this form, because like there are a lot of spelling mistakes and because of this kind of data, it's very important to learn how to clean this data. Okay, so first and foremost, the first step whenever you get the social media data to analyze, the first step is we need to clean it. Okay, so you have this data, you need to understand it. What you need to understand the context of the data. Once you understand it, you need to first clean it. So we have seen that like what all different steps you can follow while doing the data cleaning. And like once you have the data cleaning, then we have studied about different aspects or different applications of NLP. So one of the application was this text summarizations. So basically like if you have text, you can summarize it. So there were two different forms. One was extractive summarization and the other was abstractive summarization. Extractive summarization is like when you extract certain sentences, certain important sentences from your entire text. So that is extractive analysis, extractive summary. But on the other hand, abstractive summary is when like your model, it uses the text that you have given as input and it summarizes it in its own language. So that is called as generative or abstractive summary. So in NLP, there are different models and there are different algorithms that can generate both extractive and abstractive summaries. So like we have seen the demo in the last class where we have seen like how we can use these algorithms to produce these different type of summaries of the data. Then later like in the last section of the last lecture, we have started discussing about sentiment analysis. So yeah, so whatever like the statements we have, we need to we need to categorize it into different categories, like whether it is positive statement or it is negative statement or it is neutral statement. So we have seen that this is more or less a classification problem. Okay, so given a data, you need to train your models, and once your data models are trained, you can give a new sentence, and that sentence can be categorized as positive, negative, or neutral. And these are the different approaches that can be used. There can be machine learning approaches like rule based, and then there can be these different algorithms. We can use deep learning, generative AI. So all these are different things that can be used for text summarization. So yeah, So that was all that we have done in our last lecture, starting from introducing you NLP and then introducing you the application. So today we will discuss little more about applications. We'll see some more demos, and then like I will be taking you through a roadmap. So roadmap as in, just give me a second. Okay, so yeah, so these are the topics that we are going to discuss today. Let's set up the agenda for today's lecture. So firstly, we are going to discuss a little bit more about the sentiment analysis. So like we will be studying what all are the subjective sentiments and what all are the objective statements, and like why it is important to identify the subjective statements and the objective statements in sentiment analysis. And we will be seeing the algorithms and demos to appreciate that how this can be implemented. Then like we will be also seeing a more granular implementation of sentiment analysis, that is aspect based analysis. And we will see that why studying this aspect based analysis is important. Okay, then next we will be discussing another application of NLP, that is document classification. So how you, given different sentences or documents, how you can categorize them, that okay, this document is on sports, this document is on politics. So how you can categorize those. So we will be seeing those techniques. And then like I will be discussing a roadmap. So what is roadmap is like basically I will be discussing the basic steps that need to be followed in order to solve most of the NLP problems, in order to solve most of this social network analysis using NLP algorithms. So what is the basic roadmaps? So that we are going to discuss. And like if we have time, then we will start with the networks. So from the next lecture onwards, it will be mostly social network analysis. So we will be digging down deep into the network analysis, what all are the different measures. So we'll start, if like time permits, then we'll start those measures as well in today's class. So yeah, so with that, let's start with our very first topic. So in the first topic, we are going to, like in the last class, we have seen sentiment analysis. So in today's class, we are discussing it a little bit more. Like in the last class, we have only seen that how you can categorize given statements into positive, negative, or neutral. So, like, are there any other aspects or are there any other things that are related to these sentiment analysis that need to be taken care? So, let's discuss that. So, yeah. So, before moving further, I would like you to identify. Okay, so I would like you to identify these two statements. So, the first statement is the battery lasts for 10 hours. Is it a fact or an opinion? Okay. Anybody else would like to answer this? Okay, how many people vote for fact and how many for the opinion? Okay, so and then like we have another statement. We have the second statement, that is the battery life is amazing. So what do you think, that is it an opinion or is it a fact? Okay, so yeah, I have various answers now. So the correct answer to this is that battery lasts for 10 hours is a fact. But on the other hand, battery life is amazing. This is more of a subjective comment. Okay, so that's why like this is more of an opinion. So when we are studying the sentiment analysis, so it is very important to identify that whether a particular statement is a fact or an opinion. Okay, so like if a particular statement is a fact, for example, we have this first statement: the battery life lasts for 10 hours. So how will you categorize this particular statement based on sentiment? Is it positive, or it's negative, or it's neutral? So generally, like, we will say that this is maybe a neutral statement, right? And on the other hand, we have the second statement: the battery life is amazing. So we can clearly identify that this is a positive statement. So if we have more of these fact related statements in a particular corpus. So now, like, let me introduce this term. So in NLP, there is this very important term called as corpus. So corpus is when you have set of statement or a paragraph. Okay, so in the paragraph, suppose you have three statements. Out of three statements, two are the facts. Okay, and the third one is maybe positive statement. So overall, how will you rate this particular paragraph? You will rate it as maybe neutral. Okay, so when you have these statements, the statements that are fact, they will generate a bias towards neutralization in the paragraph. So you need to differentiate between whether the statement is a fact or it is an opinion. You can only do the sentiment analysis on the statements that are opinions. Okay, so you need to bifurcate these two. So you have these two things: one is fact and the other is opinion. So if you have some paragraph or if you have certain statements, first thing you need to do is you need to identify that whether it's a fact or an opinion. If it is fact, then like we will not be doing an opinion analysis on this. Okay, but on the other hand, if it is opinion, then we will do the sentiment analysis on that particular statement. So that's why, like, identifying the facts and the opinions, or the objective versus the subjective statements, is very important in sentiment analysis. So the subjective sentences, what all are the subjective sentences? They generally express a particular person's opinion or feeling or judgment. Okay, like in the last statement, we have seen that a person can say, okay, the battery life is amazing, or like it's not good. So whenever we are expressing our feelings towards something, that is called a subjective sentence, or it is called as an opinion sentence. Okay, on the other hand, whenever we have some facts, whenever we say, okay, I got a parcel yesterday, okay, or I can say that my laptop runs for like 4 hours. Okay, so these statements are the fact statements, and we need to classify these statements. So whenever a given statement, we need to classify that whether it is objective statement or it is subjective statement. So it is only useful to do a sentiment analysis on the subjective statements. So now, given few of these statements, I would like you to spend some time and like categorize the statements into opinions and the facts. So you can number it 1, 2, 3, 4, 5, and 6. Okay, so we have this very first statement, that is the phone feels cheap. Is it an opinion or a fact? Correct. So then let's move to next statement. That is, its weight is 175 grams. So is it a fact or an opinion? The second statement is fact. Correct. The third statement is the screen is stunning. So is it a fact or an opinion? Correct. So, yeah, so I think with these examples, you have understood that the difference between the facts and the opinions, and like why identifying the facts and the opinions in sentiment analysis is important. Okay, so you can see in this particular slide, I have written that, okay, the screen is stunning. This is this is an opinion. Okay, so when it is opinion, then I can categorize it into like the three categories, that is positive, negative, and neutral. So once I identify this, I can say, okay, this is a positive statement. Similarly, let's come to the last statement. The last statement is the speaker volume is accountable. Okay, so is it an opinion? Correct. Yes, it's an opinion and it's a neutral. Okay, so when you have these opinions, those opinions can be categorized into the category positive, negative, and neutral. So yeah, so although like I have already discussed that identifying these two statements, that is subjective. Subjective is when we have opinions. Okay, so it's important to understand whether a sentence expresses a fact or whether it is objective or an opinion, or that is subjective, is essential because many NLP tasks and the real world systems behave differently depending on the type of sentence. Okay, so because my NLP task behaves differently, therefore identifying these two is important. So here are the key reasons that explain that why this is important. Okay, so although I have already given you an idea about why this is important, so let's go through a few examples that will further explain you why it is important to categorize these two. So the first is that you can get more accurate reviews. Okay. So for example, if you have this statement like delivered yesterday, the build quality is amazing. So now if you closely observe this particular statement, so this particular statement has two sentences. The first one is delivered yesterday. Okay. And the second one is the build quality is amazing. So if you see those, we will categorize this particular statement into two statements. That is, the first one is this statement and this sentence, and the second one is the build quality is good. Now we will categorize it, that whether like it's a neutral or it's a sentiment. So if we it's neutral, positive, or negative. Okay, so if we straight away categorize it, so the first one is a fact. Okay, delivered yesterday is a fact and it's a neutral statement. And the second is build quality is amazing, so this is a positive opinion. So when we combine these two, this is the combination of a neutral statement and a positive statement. Okay, so the combination can sometimes confuse the machine, that in which category should I put this particular statement. So in order to avoid that, in order to obtain more accurate reviews, we need to identify whether a statement is a subjective or an objective. Second is these days we have chatbots, right? So the chatbots should understand that whether the statement is a subjective. So if it is subjective or an opinion, so the machine should be more empathetic. But on the other hand, if the statement given by the user is like, if he's asking for some facts, so he should give the information. Okay, so that's why, like, while designing the chatbots also, like for a machine, it's really important to understand that what the user is asking, whether like he's giving some opinion or asking for some opinion, or it's a fact. Okay, so for example, let's go through this example. So it says that the screen seems small. Okay, the screen seems small, it's an opinion. Okay, so if it is an opinion, so chatbot should answer in more empathetic way. For example, like what it is given on the screen. Sorry to hear that. On the other hand, if it is asking what is the screen size, so in this case the person is asking for a fact. So since the person is requesting for a fact, it should give a factual information. Okay. Yes. So yeah, so the chatbot should not answer something that is opinion. So that's why like a chatbot should categorize these two statements, that whether it's a subjective statement or an objective statement. So now let's see the third example, that is identification of the fake news. So identification of fake news is another very important research topic. So a lot of research is done on this topic, that how when you have this Twitter data, or like how do you identify whether a particular news is fake. Like I'll give you the example. Like recently, we heard that news that like Dharmender died. Okay, so that was a fake news. So how will you identify, or like on the network, like whether a particular news is fake or not? So let's first think logically. Like how will you identify that whether a particular statement or news is fake or real? Anybody? Like I'll give you one hint. It's based on the classification that we have studied in the last few example, that is that whether a statement is factual or is it opinion. So anybody would like to logically answer this question, that how will you, given some statements, given some set of statements on, like if you search news on Dharmendra, okay, so how will you identify that whether this is a fake news or this is a real news? Anybody? Okay, so whenever the news do not have the facts in it, okay, so whenever a particular news do not have the facts, like for example, this was the time, or this was the hospital, or this was, so whenever like a particular news is more opinion oriented, okay, so if it has a lot of subjective statements and there are a lot of, it's heavy on opinions, so those particular news can generally be categorized as fake news. But on the other hand, like if there are certain news and it has facts in that, in it, so those particular news can be categorized as the real news. Okay, so the real news tend to be fact heavy. Okay, so this is the logic behind identifying the fake news and the real news. So if the real news is generally fact heavy, so if it is fact heavy, so again, it is emphasizing on the fact that you need to identify that, okay, this particular corpus or this particular paragraph has factual statements. Okay, if it is fake or misleading, it's emotionally heavy. So whenever a particular news is emotionally heavy, so it will have lots of subjective words and less of the facts. So whenever we have these kind of news, so we can identify it as fake or the real news. Okay, so for example, the government is disastrous policies are destroying the economy. So if you see this particular statement, so there are a lot of subjective words and there are no facts. Okay, so if there are no facts, then we can classify it as a fake news. So yeah, I hope like with this, you all can appreciate this fact that when we are doing sentiment analysis, why identifying the subjective and the objective statements is important.
May I ask a question here? Um,
Yes.
yeah, thank you. So when you say that emotional content will be very heavy in a non-fact or not true statement,
Mhm.
but this emotional will be very heavy in some newses also, right? Let's
Mhm.
say that it crashed on a on a medical college hospital. That is
Right,
a
right.
very emotional statement, but that's a fact happened, right?
Okay, but then that news will have lots of facts as well. Okay, these many passengers were there. This particular passenger was sat on this particular plane, and then there was like news about the pilots, the details about the pilots. So those all are the facts. So there are emotional values, but at the same times there are a lot of facts. So whenever there are lots of facts, so that particular news can is a real news.
Correct, but the emotional, how we can go with the emotional value of it? It is
So
little, it is little
s-
biased, right? sometimes.
So yeah, you're right, but there, right, you can say that there can be a certain portal. Okay, so there can be a certain portal, and like that particular portal is only talking about, for example, like how like the family members are feeling. Okay, so if that particular news portal is putting only about like how the family members are feeling, so that is more of like opinion oriented. So in those case the machine will identify it as a fake news. So if going by the logics, it will identify it as a fake news.
Okay, I have another
Yeah,
example. If
yeah.
it is dragging the class, okay, it is on the same topic, like based on the social media news. This particular scenario applicable only for the cryptocurrency trading. The
Hmm.
cryptocurrency trading is is will change every minute drastically based on the social media newses. That's basically it how it operate. That is the far quickest form of news that will arrive to everyone.
Hmm.
um, that in that particular situation, what we will see is like, let's say, like, YFI is going to release another ledger.
Hmm.
uh, it's just a one liner note that comes from some authentic source or sources.
Hmm.
um, how will I validate whether it is a fake news or what it is, what it is containing is a fact? It doesn't have any emotion, right?
Okay, so yeah, that's a good question, but like I think it requires a lot more discussion that is beyond the scope of this class. Probably, like we can take this discussion offline. So
Sure,
yeah,
sure.
yeah, okay. So yeah, so like in order now, like see, in the previous class we have only studied that how we can classify the statements into positive, negative, and neutral. So now, like in this class, we have added this thing that okay, we need to identify first. We need to identify whether it's a opinion or a fact, and then we can classify it. Okay, so now, these are the different algorithms that can be used to, for this particular task. So if you guys are interested, you can dig deeper into like these algorithms. You can try to understand it, how it works, like in which particular situation, which algorithm works better. So all those things you can explore if you are interested. So generally, if we see that like how these algorithms work, so this is a flow chart for that. So you will have an input sentences. So first we will like tokenize it. So we will divide it into tokens, and then we will try to extract the keywords. Okay, so if the keywords have the words like I think, or it has some like emotional words like good or bad, like lot of subjective words. So it will try to identify that, and then like if it has those kind of words, so then it can classify it into the subjective, or otherwise it will be an objective statement. So it will be more clear to you once I show you this demo. So let me share this link with you. Okay, you can copy this and try to run this code. Okay, can you access this link? Is it working for you all? You can share the screen, like this results if you get it. Share the screenshot. Okay. So we have this library, Transformers. So Transformers is a deep learning library. Okay. So it has different deep learning algorithms. So firstly, we will load this particular model. Okay. So this is a pre-trained sentiment model. Okay, so it like it can classify the statements into positive, negative, and neutral. Okay, so now you have this list of subjective keywords. So I've told you that like if the particular sentences have these subjective words, then it can be classified as subjective. But on the other hand, if it has certain facts, then we classify it as objective statement. So how we are going to do is we are first going to take the sentences. We have defined this function that is subjective. Okay, so what it will do is it will take the sentence and it will try to search for these subjective words. Okay, so if there are these subjective words, then it will classify it as subjective. Okay, so all the sentences that have these words will be classified as subjective. Otherwise, it will be an objective. So once we have identified that whether the statement is subjective, so next we can do sentiment analysis by using the model directly. Okay, so this is a deep learning model that can be directly used. So by using this particular model, it can directly classify the statement as positive, negative, or neutral. So yeah, so this is the code for analyzing whether your statement is positive, negative, and neutral. Okay, so now let's take a quick break of 10 minutes, and after that we will discuss this aspect-based sentiment analysis. Okay, hello everyone, welcome back. So, yeah, so before discussing further, I would like to ask you one thing, like how many of you are comfortable with Python? How many of you have already coded in Python and working with Python? Anyone who do not work with Python? Okay,
I think
and
most of are comfortable with Python at this point.
okay, sure.
That's my
And
opinion.
like, are you aware of these machine learning algorithms? So basic, supervised, unsupervised learning, and so what is classification, regression? So are you aware about all these terms?
Yes, ma'am. We had that paper in the first semester itself.
Okay. So, so there can be a few students who might not be very comfortable with these terms. So let me give a quick 5-10 minutes overview about like how these machine learning algorithms work. So I will be giving a very high level explanation to this. So like when we are discussing these terms in NLP, because generally like next I will be discussing the roadmap. So in the roadmap I will be telling you an overview that how you can deal with these problems. So before that, let me give you like a quick overview of how these algorithms work. Okay, so in machine learning, in machine learning, we have broadly these two categories. One is supervised learning and other is unsupervised learning. Okay. So supervised learning is that when you have data and along with the data, you have the labels. Okay. So for example, I have a tabular data where I have maybe weight, height, length, breadth, and then I have this categorization that whether like it is a cat, dog, or human being. Okay, so this kind of data is called as supervised. Whenever we are doing something on this kind of data where we have the features as well as we have the labels, so this kind of data is called as supervised learning. Okay, on the other hand, when we only have the features, when we do not have the labels with us and we are doing some kind of analysis on that, that is called as unsupervised learning. So in unsupervised learning, generally we have the clustering algorithms. For example, in the networks, you are going to study the community detection algorithm. So in community detection algorithm, you do not have these communities. Okay, these particular people belong to this community. These particular people belong to that community. What data you have? You have the nodes and you have the connections. Okay, so based on this data, based on the nodes and the connections and the structure of the network, you identify the communities. So this is an example of unsupervised learning. On the other hand, when you have certain features with you and you have some labels, okay, so what you do is you train your model. Okay, so generally what you will have is you will have some features like F1, F2, F3, F4, and so on. Okay, so you will have these features, and these features are independent features. So you have these features, these are independent features, and you have certain output corresponding to these features.
Ma'am, I guess you are not sharing your screen.
Oh, is it? Oh, I'm sorry. I hope my screen is visible now.
Yes. Yes.
Okay. So right. So you have these features. Okay. So these features are independent features, and corresponding to these features, you will have certain labels or the output an that is dependent feature. Okay, so now these features can be anything. These can be your binary data like yes or no. Then it can be your categorical data, okay, in which you have the categories. And then it can be your quantitative data, continuous data. So the data types of these features can vary. Okay, you can have any type of data, and taking this input data and these labels. So you will train your model. What you will do, you suppose you have this huge data that consists of some 2000 rows. Okay, so now you will divide this data into training data and test data. Okay, so using the training data will be subset of this data. So you will take subset of these data and you will train your model. Okay, so how your model will be trained? Okay, these are the features, and corresponding to these features, if like values are so and so, then the output is this. Okay, so your model get trained using the training data, and then whenever new data comes with certain features, okay, so this is F1, F2, F3, F4. So suppose a new row or a new data come with certain features. So then using this particular model that you have trained on this data, the model can classify it into the labels. Okay, the labels that were there in your training data. Okay, so this is how your general machine learning algorithms work. So here your supervised learning can be further classified as one. It can be your let me write it here. Okay, so this is machine learning. Okay, I need to share my screen again. You have this supervised learning, unsupervised learning. Supervised learning can be classified into broad two categories. One is your classification algorithms, and the other is regression algorithms. And this is generally clustering. Okay, so now like in NLP, when we are dealing with NLP or when we are dealing with our social network analysis, okay, when we are analyzing the raw data from social media, so generally your information will be in the form of text. Okay, so you in the earlier data I have told you that these are the features. These are the features on which we train the model. Okay, so in social network analysis, what we have is we generally have your textual data. So because we have the textual data, we need certain algorithms that are natural language processing algorithms. So yeah, so that's why okay, now I'll discuss that how do you solve a particular problem that is from social media, okay, using these NLP algorithms. So how you will use it? So firstly, you need to know a programming language, for example, Python. Okay, so by now, like as you have shared that like you all are comfortable with Python. Okay, so now once you need the Python, firstly, you will have your input data. Okay, so you will have your input data. The first step that you will apply is what it is going to be. Anybody would like to share? What is going to be the first step when you are solving a social media analysis problem using NLP algorithms? So we have discussed several times till now. Anybody would like to answer? What could be the first step when you have your data?
When I have my data, I will use first step is to clean the data and classify it.
Correct. So the first step is going to be data cleaning. Okay. So once your data is clean, what is going to be your next step? The next step is using the NLP algorithm. You are going to do certain pre-processing in which in order to pre-process this data. Okay, so this is the first pre-processing when like each of the word in the sentences.
I'm sorry, ma'am, could you please repeat the question? I guess we lost you. You got disconnected. Hello.
Yeah, we lost her.
You got disconnected briefly, ma'am. We were unable to hear you. We briefly lost you, and when you are asking the question, you got disconnected. That's where we stopped. Thank you.
Okay. So can you please tell me what was the last thing I discussed before getting disconnected?
What is the next
After
step after cleaning the data?
Okay, so after cleaning the data, let me share my screen again. Okay, So the first step that you are going to do is you are going to divide your language or your sentences or the input that you are giving into tokens. Okay, so you're going to do tokenization and lemmatization. So these are the concepts that we have discussed in our previous lecture. Okay, so yeah, so this is the first pre-processing that you are going to do. Okay, so each word will be a token. Okay, so these are the token, and then like this is part of cleaning only, data cleaning only, tokenization and lemmatization. So once we do this, the next is like there is the second level of pre-processing. So that is generally vectorization. Okay, so in that you have these tokens, these will be converted into tokens. So what all are tokens? Tokens are vectors. Vectors are nothing but numerical values that the machine can understand. Okay, so these are your words that are converted into tokens. So each token will be converted into a vector, and each sentence will be converted into combined a combination of those vectors. Okay, so that will be a sentence vector. Okay, so each sentence will be converted into sentence vector. So now these vectors can be understood by the machine. Okay, so now here, like whenever we are doing these NLP algorithms, so these features are these tokens, these vectors, sorry, the vectors that we have pre-processed and calculated. So these vectors are used as features for your machine learning algorithm. Okay, so now when you have these vectors over this, there can be various machine learning algorithms or deep learning algorithms that can be applied in order to solve different problems. Okay, so for example, we have studied this text summarization problem. Then we have studied this sentiment analysis problem. So whenever we are solving these problems, there are different algorithms that can be machine learning algorithm, that can be deep learning algorithms. So after this vectorizations, these algorithms can be applied. Okay, so using these different algorithms, these can be applied. So two of the most popularly used NLP libraries is NTLK, sorry, NLTK. Then there is Spacey. So these are the two libraries using which, like, it has these functions that can directly tokenize, lemmatize, or vectorize, and then even like these algorithms. So in order to use these machine learning algorithm, you can use the TensorFlow library. So this library gives you the access to deep learning algorithms and your machine learning algorithms. So yeah, so this is a basic roadmap that first you will clean your data, then you will tokenize it, then you will vectorize it, and then you will apply some algorithm, some machine learning algorithm to do your task, to classify your problem. Okay, so generally your problem can be if like I say on high level, so it can be categorized into classification problem. Okay, so for example, in sentiments, first what we did is we like classified your statements into positive, negative, and neutral. So this is nothing but a kind of classification problem. So you can use different algorithms from the machine learning that are focused on the classification, and you can classify these statements into like whatever you want to classify. And then like there is another application like document labeling. Okay, so in that you basically have these documents, or for example tweets. So the tweets can be labeled as like whether it is it belongs to sports category, or it belongs to finance category, or so on. So so yeah, so labeling this is again like a classification problem. Okay, so yeah, so once you have vectorized it, you can apply various classification algorithm in order to solve your NLP problem. So yeah, so this is the roadmap for solving these kind of problems. And like you can, if you are interested in this field, you can explore more NLP algorithm. But like because we have just two lectures, and NLP is in length and breadth a whole subject in itself. So going into like discussing these algorithms and going into mathematical aspects of these algorithms is beyond the scope of this lecture. But the only thing I can do is I can motivate you towards like how these problems are tackled, or what all are the different aspects that you can see when you are seeing such problems. So yeah, so okay. So further, like there is. Okay, so till now we have discussed sentiment analysis. So this is a further fine-grained version of a sentiment analysis, and this is called as aspect-based sentiment analysis. Okay, so aspect-based sentiment analysis is a fine-grained NLP task. Why it is fine-grained NLP task? Because here we will not only be discussing about what is positive, what is negative, what is neutral, but we will also be seeing that what is the aspect or what is the entity that is being labeled as positive. Okay, so in this we are going to extract not just the sentiment that is positive, negative and neutral, but we are also going to extract the entity which is being said as positive or which is being said as negative. So like let us take an example to understand like how it works and like why studying aspect based sentiment analysis is important. So yeah, so like whenever we are doing these sentiment analysis, it is important to understand that what is being talked about. Okay, so what sentiment is expressed towards what specific aspect. Okay, so there can be an example. For example, sometimes we say that okay, my phone my phone takes good pictures, but it is but yeah, so but its speakers doesn't work well. Okay, so for example, I have this example. I say that the camera of my phone works well, but its speakers do not the sound is not that good in this phone. So now you can see that there are these two opinion statements in this particular statement. So there are these two different opinions. The first one is positive, okay, and the next one is negative. The first one is positive whenever I'm saying that the camera of this phone is good. Okay, so this is a positive statement. And the next statement is I'm saying that the speaker in this phone is not that good. Okay, so that is a negative statement. But then when we are saying a positive and a negative statement in a feedback, okay, so we need to identify that what is the aspect about which we are talking. So in the first statement, I'm talking about camera is positive. On in the second sentence, I am talking about its speakers. So speaker is has a negative sentiment attached to it. So that's why like when we are doing the sentiment analysis, it is also like especially when we are analyzing the feedbacks, it is very important to analyze the aspect behind it, like about what we are talking about it, not just like whether it's positive or negative. We also want to know what we are talking about it. So yeah, so this is an example. The camera quality is excellent, but the battery life is also awful. So the camera is positive, but the battery is negative. Okay, so this aspect-based sentiment analysis is more granular than what we have studied till now. So yeah, so aspect is generally a noun. Okay, so whatever is the noun in the sentence, that is the aspect. Okay, so now this aspect based analysis, it can be further divided into three subtasks. The first subtask is called as aspect term extraction. So what do I mean by aspect term extraction? By aspect term extraction, I mean that first of all, I need to identify the entity about which we are going to talk about. Okay, for example, in this particular statement, the camera quality is excellent. I need to identify what is the aspect. The aspect is the camera. The entity about which we are talking about is camera. So we need to identify the aspect term expectation. The second is we need to extract the opinion. So we need to extract the opinion related to this. So the opinion statement is excellent. Okay. And the third is we have to classify that opinion. So this task we have already done. Okay, so we have seen that there are certain pre-trained words that can be used that are already categorized as positive or negative or neutral. So using those words, it can classify it as positive or negative. Now we have this aspect, camera is the aspect, and excellent was the opinion related to it. And this can be categorized because excellent is a positive word, so excellent is categorized as positive. Okay, so now we have information related to the aspect. The camera is positive. Okay, so combining these two, we get aspect sentiment classification. So these are the three subtasks that are very important when we are doing aspect-based sentiment analysis. And like here, I have listed different algorithms that you can explore for each of the steps. So rule-based approach I have discussed in the last lecture. And then these are some deep learning algorithms. So if you are interested, then again, like you can uh, study about these algorithms. Then we have this sentiment classification. So sentiment classification is like that, like what I have discussed now. You have battery life. Battery life is your aspect here. Then terrible is an opinion, and terrible can be further classified as a negative. So you get the aspect and you get like whether it is positive, negative, or neutral. So this type of analysis is very useful when you are analyzing the feedbacks. Okay, so you get like exactly what is good and exactly what is bad. So that kind of extra information you get by doing this, and like this is very helpful when someone is designing new products. It's like very important application for the companies. So yeah, so these are the different terms that you should know. Or you already know what is corpus. It's the group of different sentences or a paragraph. Okay. Then document. What is document in NLP? Even a sentence can be called as document. Okay, so each and every sentence is also called a document. Document can be a list of sentences, but then if there is just one sentence, even that can be called as a document. Then we have vocabulary. Vocabulary is the list of all the unique words that are there in the corpus. Okay, and the words, as usual, like words is all the words that you have in your corpus. So yeah, this was all about sentiment classification and different variants of sentiment classification. So we started with the initial classification, so where we have these sentences and we classified it into positive, negative, and neutral. So then we added another aspect to it where we understood that whenever we are analyzing, we need to separate out the factual statements and the subjective statements. And after separating these two statements, only we should do the sentiment analysis. And the sentiment analysis is only done on the subjective statements. Okay, so after studying that, we have added this third aspect to it. So when you are analyzing the feedbacks or you are reviewing the products, so it's very important to know that what is good or what is bad in that particular product. So for that, we do aspect sentiment analysis. So in aspect based sentiment analysis, we not only derive that whether the particular statement is good, bad, or neutral, but we also derive the aspect which is good or bad. Okay, so yeah, so this was all about sentiment analysis. And now, next, we move on to our next topic, that is document classification. Okay, so yeah, so document classification is the process of automatically assigning category or label to a piece of text. Okay, so if you have a tweet or if you have a document, you need to classify it, or you need to categorize it, or you need to give it a label that what it is. Okay, so we have certain examples here. So like India defeated Australia by 6 wicket. Okay, so this will be classified as sports. Okay, so you have these different statements, and like in the previous slide, I told you that each statement can also be considered as a document. Okay, so these documents can be classified as sports, finance, technology, politics. So these are the different classification labels. So again, there is another thing to focus here. Again, like as we have the sentiment analysis problem, which can be converted into a classification problem. Similarly, a document classification problem is also a classification problem where different classification algorithms can be applied. Okay, and the document classification, again, it has a lot of application right in the social media analytics where we need to categorize the tweets. Okay, so for certain politicians, we need to know, okay, whether people are saying positive about them, how many are the positive tweets, how many are the negative tweets, and how many are the neutral tweets. This kind of analysis is really important when we are analyzing the poll results. Then we have these applications in the e-commerce where we are trying to review the product. Okay, so we need to know that, okay, about what product people are talking about, what is trending, and like in which particular field or in which particular on what, like what products a company should advertise more. So all those type of application need this kind of analysis where we really need to take the data from social media, and we need to analyze it, and we need to categorize it or label it that what people are talking about. Okay, then we have cyber security. Again, we have to classify that whether a particular email is a spam or is a ham. Okay, so yeah, so in that also, like you need to label it or you need to classify it. So that is an application in cyber security domain. Then even in the healthcare and like other departments, it is a very useful technique. So yeah, so these are, again, so as I have told you that this is a classification problem. So again, these are the approaches that can be used for your document classifications, and these are the libraries that are important for that. So yeah, so with this, we will end our topics on NLP, and we will move next to our discussion on networks. Just give me 1 minute. Okay, so now let's start discussing about the networks. Okay, so see, in social media network, most of the social media analysis, most of the data that we are going to see is the network data. Okay, so that's why like understanding different measures of networks is very important. Okay, so we will be in this lecture now, in the next few lectures we will be discussing about the network measures. We will be discussing the what all different algorithms you can apply to achieve like different applications, for example when we are clustering or when we are doing link productions. So in all those, what all algorithms are required, and for that we need to discuss in detail the network measures. Okay, so yeah, so like in the first lecture I have briefly discussed about the networks. So networks is nothing but a set of nodes and the edges. Okay, so what is a network or a graph? Graph is GVE. Okay, where V is set of nodes and E is set of edges that connect these nodes. Okay, and like we have a lot of examples of networks around us. So like starting from the social media network that we have been discussing in the last two lectures. So we have these Facebook data, then Twitter data, then all the social media network data. So in those kind of data you see that each node, it represents a person. And for example, if we take an example of the Facebook data, so each node is a person, and if they have a friendship relation between them, so if two person are have friendship on the Facebook, so then this network will have an edge. Okay, so this is P1 and this is P2. So this is a network data where each node represents a person and each edge represents the friendship relation between those two persons. Okay, and then other than these, we have like other than social media analytics or other than like social media, we have another examples like our road networks. So in road networks, each node, it represents a city, and like the road between two city, it represents an edge. Okay, then like for example the airline network data. In airline network data, each airport, it represents a node, and then if there are flights going between two airports, that represents an edge. Okay, so yeah, so these are the different examples, and you can see that like there are a lot of examples around us. For example, food web. Okay, so this is another example of networks we have. Then we have this Twitter network. So remember that Twitter network is a directed network. Okay, so if one person is following other person, then there will be a directed edge between these two. So from this we can analyze that the networks can be further categorized into different categories based on undirected. It can be undirected networks. So in undirected networks, the edges do not have any direction. For example, in the Facebook network, if like people, they are friends on Facebook, then they will have an undirected edge between them. Okay, so but on the other hand, the Twitter data is a directed data. Okay, if A is following B, B need not follow A. Okay, so yeah, so that is a directed network we have. Then like other than directed, undirected, we also have weighted and unweighted network. So for example, I took an example of airlines. Okay, so in airlines, different nodes, they represent the airports, and the number of edges that the number of flights that run between those two airports can be considered as a weight of the edge. Okay, so the number of flights between the two airports can be considered as weight of the edge. So yeah, so you can see that the graphs or the networks can be categorized as ordered, unordered, then it can be weighted and unweighted. Unweighted networks are those where the edges do not have any value. Okay, so all the edge weights can be considered uniform or one in that case. So then we have another category of network, that is static and dynamic network. So static network is when your network is not changing over time. But on the other hand, the real world network, the real world data that we have, for example, the Facebook data or like tweets we have. So these are the networks that are continuously changing. Okay, so people are changing the communities, people are talking about different things. So this type of network that continuously change is called as dynamic network. Okay, so depending on these categorization, like whether it is ordered, unordered, or it is directed, undirected, or it is static, unstatic. So depending on these categorizations, we have different measures that we are going to discuss. Okay, so yeah, so other than Twitter data, there can be this citation network. So what all are citation network? So you see that here, these are, this is a timeline. So this is the timeline for the papers when they are published. So each paper, it cites different papers. Okay, so each paper, like it cites different papers. And if you can see that one paper can only cite the papers which were there before that particular paper was published. Okay, so yeah, so one paper can only cite the previous year's papers. Okay, so that's why you can see that in this timeline the time is in the decreasing order. And like even the citation network is a directed graph, you can see. So there are these directions, this paper is citing this paper, but then that doesn't mean that this particular paper will cite this paper. Okay, so yeah, so that's why like the citation network is a directed graph again. So there is another variant of the citation network that is very popularly studied, and that is called as co-author network. So co-author network, two authors will have an edge between them, or the relation between them, only and only like if they have published a paper together. Okay, so all those people who have published a paper together will have an edge. So this is called a co-authorship network. So now this particular network that I'm talking about, the co-authorship network. So in this, like we have these edges. So can anyone tell that whether it's going to be a weighted graph or an unweighted graph? So if it is a weighted graph, then what is going to be the weight of these edges? So I have this co-authorship network. So in co-authorship network, if two people have published together, then there will be an edge. So like I'll reframe my question. So if this is a weighted graph, so what can be the weight of an edge? Anybody?
I'm just giving a try. It's going to be 50,
It's going to be
50%.
okay. Okay, like how much percentage a particular person has contributed. So like that's what you are saying? 50.
Yes, you're right.
Okay.
Exactly.
Okay. So generally, the contribution that we do towards a paper is not quantifiable. So it's very difficult to quantify that, like how much work which person has done. So yeah, so the edge generally represents a relationship. Okay, so since this is a co-authorship network, as the name suggests, that these two people have published together, so the edge weight can be the number of papers that these both people have published. Okay, so the number of times these two authors have published together, so that can be the weight of the edge. So yeah, so different type of networks can be formed based on their attributes. So now this is an example of an internet. Internet is again a network data, and it is a huge network. And in this, like, each web page is a node. So each web page is a node, and if that page has link to other page, so then like those two pages are connected. Okay, so this is again a directed graph. So the internet graph or the World Wide Web graph is a directed graph where each web page forms a node, and like if one web page is referring to another web page and there is a hyperlink to that page, the another page in this particular page, then there will be a connection, directed edge from this page to the page like to which it is referring to. Then we have this network of roads. Yeah. So so these all examples are given that so that like you can appreciate that there is a lot of data around us that is in the form of networks. Okay, so not only this, like now we are a part of bits. Okay, so this again can be like converted into a network data. Okay, so I am a faculty, I am connected to you, I am teaching you this course, so we have this connection. So each type of data can be converted into a network data. Then like you have this family tree. Okay, so you have in your family, like you have your father, the father has like his own father. So we have this family tree, and family tree can be again considered as a network. Okay, then you have your friends around you, your friends further have some friends, they further have friends. Okay, so like in real world we have a lot of network around us, and we need to have this capability of getting the information from this network and analyzing those networks, and that is what like we are going to do in this particular course. And then like when we are talking about these networks, so then like there are these two fundamental things that are very basic and very important, and those are the nodes and the edges. Okay, so nodes can also be called as actors, vertices, vertex, and edges can be called as ties, links. So yeah, so as I've told you that graph or the network can be expressed as a subset, as a combination of V comma E, where V is a set of vertices, and this is the size of the graph. The size of the graph is generally expressed by the number of nodes it has. And this is the set of edges or the ties between those people. So yeah, so then there can be directed graphs and the undirected graphs. So in the directed graphs, this particular order, okay, so each edge is represented by a combination of two vertices. Okay, so if we have an undirected graph, this particular order, that is V1, V2 or V2, V1 is considered as same and it won't make any difference. But on the other hand, if a network is a directed graph, then this ordering is very important. So if we have this edge V1, V2, that means there is a directed edge from V1 to V2. Okay, so that's why this ordering is very important when we talk about the directed graphs. On the other hand, the ordering between the vertices is not important in undirected graph whenever we are expressing the edges. So yeah, I would prefer that other measures we will study in our next lecture. So in next lecture, we will start with the network measures where we will be discussing the degrees, the centralities, and modularity. So all those different measures we will be studying and how they are different when it comes to directed graphs, undirected graphs, weighted graphs. So all those mathematical aspects related to the networks we will see in our next lecture. So yeah, so that's all for today class. So we will discuss more today. Like I just wanted to give you the introduction and about the networks, and we will discuss the detail and the mathematical elaboration of these measures in our next class. So yeah, that's all for today class. Thank you for being a lovely audience. Thank you everyone.